Work out the value of 1.5 square. 1.5 square is 1.5 times 1.5. We know 15 times 15 is 225. So 1.5 times 1.5 will be 2.25. Complete this number machine so that y is 4x plus 5. So if you input x, the output has to be 4x plus 5. So how do you go from x to 4x plus 5? We times it with 4 first and then add 5 to it. So times with 4 to make it 4x and then add 5 to make it 4x plus 5. Complete this number machine so that y is 3x minus 24. So if the input is x, the output has to be 3x minus 24. So going from x to 3x minus 24, I times it with 3 first and then take away 24. But I see there is this times 3 here. So I have to make an alternate approach here. So instead of timesing it with 3, I will take 3 common from these two terms to make x minus 8 remain inside the brackets. So 3 times x minus 8 is equivalent to saying 3x minus 24. So now using the other expression and see what is happening here. Here I take away 8 first from x. So x take away 8 to have x minus 8 and then times it with 3 to give 3 times x minus 8. So which is equivalent to saying 3x minus 24 as the output. Complete this number machine so that y equals x. So if the input is x, the output is y, which has to be equal to the same input. When can this happen? When the inside operations are reverse of each other. So if I'm times with 6 and then I divide by 6, what do I get? So if x times 6, I get 6x and then divided by 6. So 6x divided by 6 gives the output as x again. Each number in a list is increased by 10. Tick one box for each statement. Well, we don't have any list or the data given to us, but it just says that every number in the list is increased by 10. Now, what effect will this have on the mode, median, and the range of the data? So, will they also be increased by 10 or not? We have to figure that out. So, let me take any random values, maybe 2, 4, 4. So, suppose I have this data. Every number is increased by 10. So, if I increase 2 by 10, I get 12. 4 by 10, so 4 plus 10 is 14. This also will be 14. So, previously, the mode of my data was 4. Now, the mode of the data is 14. So, has it increased by 10? Yes. Previously, my median was 4. Now the median is 14. So the median also has gone up by 10 units. So I would say yes, this is also true. What about the range? Previously, the range was the highest value. You subtract the highest from the lowest. So 4 minus 2 is 2. Now the highest is 14 minus 12 is again 2. So here we see the range is not altered even though I have changed the each and every number in the data. So the range is also increased by 10? No, it's false. The range remains same. Write the missing term in the geometric progression. We have these numbers given here which are like in geometric progression. So they progresses geometrically. What does that mean? We have this common ratio. So if you divide the second term by the first term, so that's 4 over 1 will be equal to 16 over 4 will be equal to the next term divided by this term. So all these ratios will remain same. That's what we mean by geometric progression. Well, instead of doing all that, we can do one thing here. We see the first term is 1, the next term is 4. So what do I need to do to 1 to make it 4? I do times 4. So the next term will be times 4 again. The next will be times 4. So 16 times 4 is 64. The answer for this is 64. A Fibonacci type sequence begins from 5 and then -9 and it goes on. The sequence is continued by adding the previous two terms. Work out the next two terms. So we have been given first two terms of a Fibonacci type sequence. We have to figure out the next term. So the next term you get by adding the previous two terms. So these two terms, if you add, you get the next term. So 5 plus -9 is -4. This is the third term of the sequence. The next term will be the sum of the previous two terms, which is -9 plus -4. So -9 plus -4 will be -9 minus 4, which is -13. So it just wants you to find next two terms. So they are -4 and -13. Here is a solid prism. How many faces does the prism have? We see the base of this prism is a hexagon. It has got 6 sides. So for these 6 sides, there will be 6 faces. And plus these two bases, the bottom and the top, is being added to get total 8 faces for this prism. The prism has volume 3500 centimeter cube and length 20 centimeters. Work out the area of the cross section of the prism. So we get the volume of any solid or the prism by timesing the area of the cross section with its height or the length of the prism. We have been given the volume as 3500. Area is unknown. We are trying to figure out what that is. And the length is 20 given here. So from this we can figure out the area by dividing 3500 by 20. So these two cancels out. 350 go. So how many 2 goes into 350? So 2 ones is 2, 2 sevens is 14, 2 fives is 10. So the answer is 175 centimeters square. This is the area of the cross section of the prism. Work out 1/1/5, take away 3/10. Give your answer as a fraction. You can use the traditional method of subtracting two fractions by first changing this mixed number into improper and then subtracting the other fraction from it. I'm going with a slightly different approach here. What I can do instead of doing all that, I see there is some connection between these two denominators. So if I do this times 2, I get 5 2s is 10. So I do the same thing for the numerator as well. So now this fraction, this mixed number is 1/2, which is equivalent to 1/1/5, of course, and -3/10. Now 1/2 can be written as 1 plus 2/10, and there is -3/10 here. I'm trying to only focus on this part of the fraction. So 2/10 take away 3/10 gives me -1/10, and there is 1 here. So if you take 1/10 from 1, what do you remain with? You have 9/10 remaining. A large circle and a small circle are shown. The radius of the large circle is 12 centimeters. And the ratio of the large to the small circle radius is 4:1. That means we have got the radius of the large circle as 12 centimeters. What will be the radius of the small circle? They are in the ratio of 4:1. So we can manipulate it in this way. How do you go from 4 to 12? You times it with 3. So you times this also by 3. So 3 times 1 gives you 3. So the radius of the small circle is 3 centimeters. We have got the radius of small and the large circles. We have to find the shaded area. Shaded area is the area of this large circle. From that, you need to take away the area of the small circle to to give you the remaining shaded area. So we have to figure out the area of the large circle. From that, you need to take away area of the small circle to get the shaded area only. So how do you find the area of the large circle? We have got the radius of the large circle as 12 centimeters, and the rule to find the area of a circle is pi r square. So I use the same rule, pi times r is 12 here, 12 square. From that, you take away the area of the small circle, which has got the radius 3 centimeters, so pi times 3 square. It wants the answer in terms of pi, so I will take pi as a common thing from these two terms to have 12 square minus 3 square remain inside the brackets. So calculating this, 12 square is 12 times 12, which is 144, and 3 square is 9. So 144 take away 9. So this is 135, yeah? So I have 135 pi as the area of the shaded part. In this part, assume that each person works at the same rate. 10 people can complete a job in 9 hours. If 15 people work on the same job, how many hours will it take to complete the job? So there are these number of people and the time it takes for them to complete a certain task. So if 10 people are working on a task, they take 9 hours to finish it. If 15 people work on the same task, assuming they are working at the same rate how much time will it take for them to complete the same task? Well, without even telling the answer, we can see that if the number of people has gone up from 10 to 15, if there are more people working on the same task, uh, will the time be more or less than 9? So if previously there were 10 people working and now 15 people, more people have joined to complete the same task, so they will obviously complete it in less time. So this is an inverse relation problem where one quantity increases, the other decreases. So this is inverse proportion. So we have got this equation for inverse related equations, where if P is the number of people and T is the time, they are inversely related to each other. So we write it as P is equal to K over T, where K is some constant. If we figure out what is K, we can find the time required for 15 people. So first, taking these two values for P and T, P is 10 and T is 9, which gives the value of K as 9 times 10 is 90. So using this value of K, now writing the same equation now. Now instead of P as 10, I'm taking P as 15 because the number of people are now 15 and K is 90. What will be the time? So T will be 90 over 15. So I times with T on both sides to get 15T is 90 and then T is 90 divided by 15. So 15 goes into 96 times. So the answer is 6 hours. So 15 people will will finish the same task at the same rate of work in 6 hours. In fact, of the 15 people, 6 work at a slower rate and 9 work at a faster rate. What does this mean about the number of hours it will take to complete the job? So, for the same job, it says that out of the 15 people, 6 of them work slowly and 9 of them work faster. But then we don't have any specific value which says that by how much value has they slowed down or by how much they are doing it faster. So this information, using this information, I cannot do any mathematical calculation to say if the 15 people will take more than 9 hours or less than 9 hours or equal to 9 hours. In fact, this information is insufficient for me to make any statement. So I would say it is greater than answer, same or less. We can't say anything about them. I would say it's not possible to say anything. We have been given these two vectors which are added to get the answer as 520. That means the x coordinate is, or the x part is 5 and the y part is 20. You have to work out the values of these a and b. So how do we read these? So if a is added to 1, a plus 1, the x parts of these two, the x coordinate of these two vectors are getting added to give 5. The y coordinates are getting added, so that is 2 plus 3b to give 20. Now what is a? If a plus 1 is 5, then a is 5 take away 1 to give you 4. If 2 plus 3b is 20, then b is 20 take away 2, which is 18. Then b is dividing with 3 on both sides to get 18 over 3. 3 goes in 18 6 times. So the answer is a is 4 and b is 6. Clive owns 2 coffee shops, A and B. Out of 150 people, 18 people use both shops. 46% use shop A, 2/5 use shop B only. Complete the Venn diagram to represent the information. So this is the universal set. We use this denotion. We use this to denote the universal set. That is the entire set of all the people, which is 150. And A is the sphere A here represents the people who use shop A, and B represents the people who use shop B. So we have to complete the Venn diagram here with the information given. Here we see there are 18 people who use both shops. So 18 lies at the intersection of these two shops or these two spheres. So 18 goes in here. 46% use shop A. So 46% of 150. Now how many are there? So we can go with like maybe 10%. What's 10% of 150? 10% of 150 is 15. So 40% will be 15 times 4, which is 60. And to get 46%, I can find what's 1% of 150. 1% of 150 is 1.5. And then 6% will be 1.5 times 6 to give 6 5s is 39. So 6% is 9. So 40 plus 6, 46% will be 60 plus 9, these two values, to give you 69 people. So 46% of 150 is 69. Now 69 use shop A. That means it's this complete region is for 69 people. So 18 is already been included here. So you need to exclude that 18 from 69 to get the people only using shop A. So 69 take away 18 is 51. So this value is 51. What else is given here? 2/5 use shop B only. So 2/5 of 150 is, it's like 150 divided by 5 is 5 3s is 15, 30 times 2 to get to give 60. So 60 use only to use shop B only. So this is exclusively for shop B. So now let's check, have we covered all 150 people here? So 51 plus 18 plus 60, 8 plus 1 is 9. This is 6, 7, 8, 9, 10, 11, 12, 129. We have covered 129 people out of 150. So how many people are remaining now? So this is 10, 4. So 10 take away 9 is 1. This is 21 people are remaining. So where would they go? They are not using either shop A or B. So they remain outside somewhere here in the universal set. So I can write them here. This is how we complete the Venn diagram.